Hello, and welcome back again. The ever-continuing and never-ending saga of how to explain this code modification. Uh, now, uh, there's a chance that this might uh, be uploaded. Certainly, the last few attempts failed. And failed because it takes a long time. It appears to take a long time to explain this for some reason, even though it's fairly straightforward. But so anyway, why waste time explaining that it's going to take time? Okay, this is the situation as it was, almost, before I made my changes. Some of them I made. I didn't do all of the changes because I don't want to have to redo them again in recording. So what we have in TS Windows, that's where I am, is a class called systray window, derived from TS window. Fourth is an override, which is a callback type thing, and has all these various functions to do with manipulating the system tray. Now, the idea, as I told you, or explained previously, was basically to make this a class that does not derive from TS window, to take all of this functionality and make a new class that doesn't derive from TS window, but it's just a class on its own, and also requests implementation of this callback. And we're still going to make a class with this name, but it will contain rather than derive from that other class. That way we can derive from window, and we can stick the other class inside here, and we don't have any problems to do with pointers and dynamic casting or anything. In fact, I went back and I changed everything to reinterpret cast, and it works fine. Just to show that what we have is the simplest possible situation of linear derivation of one class from another, which means that we can interpret the base pointer as being any class in the hierarchy from the base. Yes, but before proceeding, I'm going to show you my new wallpaper. I just made another collage type one, and so that way you get 4 for the price of 1, essentially, in this case. I think this person is famous. This to me looks like a Native American woman. It's quite possible, though she could be Asian. Native Americans and Asians have a similar look. I don't know who this is, if she's famous or not, and I would very much like to know exactly who this is, and where she lives, and her phone number, and email, and all the other details that would be necessary in order for us to commit to marriage. Let's see. Now, that idea should be simple enough. So I don't really need to go over what we already had. You've seen it. I took this number defined thing, which helps me make do the sort of public, private, public switch, and put that into common. I'm going to go to the real project, and my previous attempts I spent too much time here, so I'm going to skip that this time. Try and just start out where I am. But I have a slight advantage, and that's this diagram that I made in the meantime, so that you can get a pictorial view of what the code looks like now as it stands. Now, as far as the class hierarchy goes, there's this system tray manager class, which is the thing all on its own. Okay. If I have a system tray application, such as toTray or quick list, as before, I derive from systray window, and that in turn derives from window. No problems there. And exactly the same for dialog. So that's the hierarchy. It's just the same as before, a three-stage thing. But inside of systray window and systray dialog, secretly another class is created, which derives from this class and does some stuff. And the stuff is as follows. First, now I've got the hierarchy, and I'm displaying the interfaces and where things are implemented. Systray manager on its own, well, it subclasses I shouldn't really say hwind, subclasses whatever window. Well, hwind's okay, because both of these have hwind. And it begs of anyone who derives from it to implement this function. So you could never actually declare one of these, you have to derive from it and then override that. Okay, so that's just what it is on its own. On the left-hand side, here's our window. Now, as usual, TS window requires the end user to implement this. And I too would like, and in this scenario, I would like that requirement to remain. So no implementation of this function will occur in here. That's still left up to the final class. Systray window, in exactly the same way as systray manager, requires the implementation of this same message callback with the same name exactly. Now, since this systman is an actual object that's derived from this, it will have had to implement systray manager's callback function. So systman, which is given the name of it the variable that is a system object inside of here is called mManager, and it implements on sys_tray_message. It's not indicated here, but its implementation is quite simple. It simply tries to call this function. And the way it tries to call this function is another thing that I haven't indicated here. It happens to have, oops, it happens to have as a member a pointer to the containing class. We need to make it clearer. So it has a pointer to a sys_tray window, which happens to be this sys_tray window. And so therefore, when it receives the on sys_tray message, through this pointer it can invoke this function, which in turn is implemented down here. Same applies on the other with the dialog. They're completely analogous, no changes, except for when the word window changes to dialog. It even fits right. Okay, so this object has a member pointer to the outer shell, implements that, uses that pointer to call this, and because of the way that this thing works, by subclassing hwind, this part doesn't happen automatically. It happens somewhere in here. There's a function that has to be called, something like the init function for mManager. It has a function called init for something, which you pass an hwind value to, and that function subclasses the entire window so that the real window procedure, whatever originally was, gets replaced with another one, so that this can do its thing before anyone else. Alright then, as far as the header file goes, here's sys_tray_manager. Now all this thing does is prevent any copying. It's kind of object you can copy, or would want to copy. These, I guess before had m underscores in front, but I put them in a struct. Simplicity, except for the string. I only put simple things in these structs, no classes. Everything else is the same. Here's the function I told you about. I guess it's not called init, it's called setHwind. Now this function has to be called before anything else. It doesn't say that exactly, but I think an assertion will fire. Yeah, an assertion will fire if you fail to call this first. And there's a question beside the assertion asking you if maybe you forgot to set the hwind. Okay, and everything else is the same, pretty much. It's all the same functions. Now, there are some static function. I should really list these in this order. So this is the window croc that replaces either, no, that replaces whatever the original was. In the case of a TS window, that would typically be TS Windows static window croc here. Okay, so initially this is for a window thing, not a dialog. The win_proc is this function, static global, and it retrieves this pointer from the system's data area in order to call the member functions of the classes derived from this, so that each one gets to have its own context. That magic happens. Well, first, you can forget about this. This has to do with controls, not with our top-level windows, like dialogues and things that we're making. It turns out that the way that the TS window is created, the way that create call is made, create window I should say, is called with an optional parameter, and the optional parameter is this pointer of one of these type things. So therefore we can reinterpret this this is a pointer to void, as a pointer to a window a pointer to a window, TS window, and use it to either modify its data about it or call functions, virtual functions in particular, and see what happens. Now this is the call at WM create. This is the way it's always been. The first step is to take what we got passed in from this struct. Now that struct just came in as one of these parameters, and you can see where it's declared here, L param. And then what we want to do is store that permanently somewhere related to the hwind, so that we can retrieve it. So that given hwind, we can retrieve this value whenever we like. Okay, that's all there is to that. And in subsequent calls, we retrieve the user data bit from the system's structure, where we would have stored this pointer, this pointer. Many windows could be using the same function. This code, the same code. If that happens to turn out to be null, and sometimes it does, even though we might be in a WM create call, there are a few calls that occur before that, that pass through here, and there may even be some calls after WM create. I think we're safe at that. It's possible that calling this even on WM create may cause the re-entry into here, in which case we skip over this. But by that time we will have set the user data to a meaningful value which we can use. Alright, now I was consistent with myself in changing everything to say reinterpret cast to ensure that there's nothing fancy going on here at all. All we're doing is we're just saying, okay, this is a that. And we don't need to find any offsets or anything, as long as the derivation as it is linear. That pointer could be thought of as this type of object, right? Because it is. It can also be thought of as this type of object, because it is. Or this. Doesn't matter how you look at it, it's all of these things. Okay. Now, what next? So that's just how the window things work and always has worked. Now what about the manager thing? So for the new class, did I show you my wallpaper? Just trying to keep you awake here. Just have a, just browse around, let your eyes wander, and let your mind imagine whatever you like. Here's the class. Systray window derives from window. Cannot be copied. It is friendly with Systray manager. They got something going on. Here inside of Systray window, protected, is another class deriving from Systray manager, which we just saw is what we had before, taken with the window bits taken out. The systman class contains one member called pcontainer, which is a pointer to a Systray window. It happens to be the class in which this object is being declared, and happens to be will be a pointer to the class for which this here is the actual instance of it. This object will be associated with, and that's true because when we construct the Systray window, we construct a regular window, and then I have an interface to pass this pointer of the outer shell into mManager, just like that. Okay, nothing more to it. I don't even know if that probably doesn't need to be public even. After I made this, no, just doesn't matter. You'd be foolhardy to call a function like that, right? But I could put an assert in here if I wanted to. And I could just return to empty R. Okay, so it's true. It's true that this is public, but the first person to get a go at it is this, and by the time anybody else gets a chance to call this function, it's too late. Guarded and protected. So I can make it public. No, that's it for a systray window. You've seen the other code. The only thing that is missing in this story is how this all works. Like how does the subclassing work and so on. And that can be shown here. Now, this set hwind, which is a member of that systray manager, is the one that must be called first by the client, and assertions will go off if they don't. Now this here is not necessary. In fact, well, I never like to put a function in an assertion, but there's no harm in doing this. What I'm asserting here is essentially that everything is going correctly. What this function does, and it's not a member function, it's a was up here. It's a static member. It takes no this pointer. Okay, it's supposed to retrieve a this pointer. No, I wouldn't need that in this particular case because this here is a member function, right? So all I'm doing here is just asserting that everything's going okay. I retrieve the this pointer using my magic method, and then assert that that value is equal to this pointer of this manager. So that ensures at this point that everything's going okay. If this fails, then something went wrong. And not to deal with that, but if it hasn't gone wrong yet. And being bold, again, all this reinterpret casting, no dynamic, nothing. So just ignore this for now, and we'll see. Next, look at the next line. Now this is a member of the manager. The M struct I showed you has these various members, and one of the members is a wind proc, and that's the previous window proc. And we're going to subclass it just as I showed you before, and what we're going to put in place of the original window procedure is our own window procedure, even though this thing isn't even a window. It's not derived from a window, and it's not a window type or anything like that. I can still replace the window procedure with this and chain to a real window procedure afterwards. And so that's all there is to that. So I'm asserting that there was a previous procedure. Probably, I guess that's pretty much assumed, and that it wasn't already set to this. What is that? That is the again global static function. global to everything, static, actual window procedure function, there's an L result and everything. And when it gets called, it wants to find out what this pointer is for the systray manager member of the window with this hwind, so that it can call the member functions using the this pointer. Now that's not the this pointer of the class, right? This is the this pointer of one member of the class. And how do we do that? First, there are two cases. If the class happens to be a dialog class, then we're in actually this I don't need this part anymore. This part is a fixed. I move. That's fine. Not this as it is. Oh, no, it's not fine. This cast is different. If the class name is that's the class name of a dialog. You can call it's fine. You know the dialog I should have used in my example, just for fun last time. Oh no, it's not the same. See, the desktop window is also of a standard type, but it's called desktop. I thought it was a dialog. Okay. So it turns out that this is the identifier for a dialog, and at least prove that much. There's a dialog. Here's a spy. Refresh. There. 32770. 32770. Now, that's the name, the class name of all dialogues. For things whose class name is just a string representation of its atom number, like if you convert this to hex, you get the atom in hex of a dialog. $8,002. And so that's all there is to that. Now what I want to do is get the user data, which is stored in not in the same place, stored in two different places depending on whether or not we're dealing with a window situation or a dialog situation, and those two different places are a regular window. The user data section is used, this particular offset, into the window system's data struct, or for a dialog, we store it here. Now that just happens to be the way that those classes work. You look at PS dialog, where does it store the user data? Well, that happens in here. See? On init dialog, this is the dialog proc stuff. An actual dialog proc, which returns a bool, But this is static, remember, non-global. When the WM init dialog comes along, the optional parameter, instead of being part of a struct, is simply the value of L param. So now we're setting at this offset in the window struct. A special place for dialogues are the L param of the previous dialog prompt. Sorry, of our this pointer, not the previous dialog prompt. Our this pointer. It's passed in L param. If you don't believe me, if you get the where is it actually sent in? It's in the bottom. Here in the bottom. Then I call to dialog indirect something dialog something param here. H instance template handle the parent window procedure and optional parameter this. What is this? This is a TS dialog. So the thing that is pointed at in the user data for the dialog is a pointer to a TS dialog, right? But it's also a pointer to a TS sys-tray dialog because we can interpret that as that pointer as being any one of these types. Same on this side. All right, what am I doing with time? Okay, almost there. Getting back to this. System Tray Manager wants to retrieve in the global function the this pointer corresponding with this hwin and the this pointer for whatever type of object we're dealing with. We don't know. But what we do know is that in both cases there's a member called mmanager, which is a systman and has a pointer in it. Well, sorry, mmanager. There's an mmanager in there, and that mmanager is a sys-tray manager because systman derives from sys-tray manager, and that's the one we want. How do we retrieve it? Well, I just showed you. The dialog is there. If not, it's here. So retrieve that pointer, cast it correctly to the type that it would be. If it was a dialog scenario, that thing would be a sys-tray dialog star. Okay. And then within there is an mmanager. And all we want is the address of that mmanager. I could have returned a reference or something, but I think a pointer is better in this case. Usually we think of this pointer. Now this mmanager, as I said, is a sys-tray manager, right? And it's the one associated with that hwin. So that gets us this pointer of the manager within the TS sys-tray window or dialog object, and therefore having this pointer, we can call the isPrivateMessage function ourselves without anybody having to know anything about it. And isPrivateMessage does some handling This notify taskbar created, handling auto or non-auto mode, calling the callback if necessary, deleting the icon on destroy, and so on and so forth. And that's all there is to that. Almost. Let me just double check one thing. No, I always do this. Okay. I was just wondering if the WM destroy was going to get processed down here. It will. So we will get. It will take the icon away on destroy. There's one other thing it does on destroy, which is replace the window procedure with the previous one. It's not really necessary to do that, but I wanted to make sure to detach this object from the window entirely. Call the window procedure, the original window procedure, with the WM destroyed message, and then a special function which will invalidate this object. So if anyone tries to use it beyond this point, they'll get an error. Otherwise, just return the result of calling the previous window procedure because it's subclass. And that's it. Okay, now let's look at one example quickly with list. Derives from systray window. Now here is a side derivation, and you might think that that would be a problem, but it's not, because at this point, that's after it's fine at this point anyway. For one thing, this thing has no virtual functions, so that might as well just be a memory. And for another, all derivation in this line is linear, and so this can't propagate itself backwards. So we're safe to do that. Has to override WinProp. It happens to override WM close, and there's a systray message, and some stuff from before. Get data. What is this? I remember making that. I don't think it does anything. I don't think it's implemented. I think that's just a hangover from when it was being implemented here. Yeah, it was just leftover garbage. Okay, so how about the implementation? WM create centers the window, which is completely no use whatsoever. It never gets shown, but I just wanted to put some function in there to see if it did anything bad. Then I call the set hwin thing for the manager, and init the tray icon. Same as before, except we just added this bit in front. Menu selection, everything's all the same. Open file, new file, all that's, nothing's changed there. Nothing's changed here. Nothing there. It's all the same. And here's the callback, same as before. So the only changes to this project are these two, and that's it. Well, and the removal of a call. Previously, there was a call to his private message. That's gone. That's handled automatically now. I compile this thing, and I'm just going to run it, and hopefully it works. Okay, it's there in the corner. See, it's working. It's country code. The right mouse buttons will work, and I have, as you know, right. I haven't explained how I do it, but there's a right-click support for that list. The way I do that, in fact, there might be some interest if it's easy to find. A R button up. I get the cursor position. If I get an R button up message from just the word, I get the cursor position, and I walk through the list of items, and for each of the items, get the rectangle associated with, and all this is in screen coordinates, by the way. Get the rectangle of the item, so that's this list here, right? And if that intersects the cursor, then I know which item was selected, and I can delete it or not. Now, anyway, that's internal handling. That has nothing to do with the sys-tray part, because I'm doing the menu, this menu on my own here. Somewhere. Let's do something with menu. At some point there's going to be a track menu. Oh, and the callback, of course, naturally. When the callback gets called, then I call this track pop-up. Now that's like almost like another dialogue, and I actually R button down here. I should use the same method as this instead of what I've got here. This is the best way to do it. Modally, nothing gets into the win prop. I know that I'm going to get messages these sorts of messages in my WinProc in only one scenario, and that is when the menu is operating, because the window's hidden, so it can't receive any input from anywhere else except that menu, right? But I don't need to make any assumptions or use reasoning or anything. I can just change that to just add the word modal, right? And then this thing, it says true here, but really what it means is 1. This thing returns an index of the item selected. That's all it does. 0 on error. So you want to make sure that your indices don't start at 0. Alright, now you've seen it work. Let's see if the exit works. that works. To tray should have already been built. It's working. Okay, now that's using the what I just compiled, and it's working. Now, where's the dialogue one? You asked. You ask indignantly. It's there. Here's the dialogue version of it. Exactly the same. Everything. This code is identical. So what I want to do is take this and just make a template class called systeman, which takes as its template argument not this, but this type. So I would just declare a systeman bracket bracket systray dialog, and I'll put the code somewhere else, and everything else the same, and that'll be the end of the story for that. For as long as I can foresee system tray support. Done. Alright, I think I made it actually. I think I might keep this one, and I'll even have a peek at a different one. Let's see which one is one. This is quite nice, really. Now, if anything were anime, or however you're supposed to say that word, this would be a good candidate. Because, like this smoke looks, it is like, see, somebody's drawn a bird here. This is just like that other one with the skull. This was made by computer graphics, and probably so was she. You know, if they can make the other one, this would be easy. Look, it's like simple circular things. I don't know about hair. They have algorithms, you know, that they can produce hair, like without having to take a real photograph and copy it. There are algorithms that will produce these kinds of patterns that build on each other as hair would. You know, as hair grows, depending on how it comes out of the follicle, you get different shapes, I guess. I don't know. I have no idea how any of these things work, but I know that they exist. This is actually probably pretty easy. You can start out with the unknown pattern for a bird, and then just make a few modifications. Alright then, so that's it, and I'll think of something next. I keep avoiding the one thing I really want to do, but I just can't figure out how to get it going on the editor project. But at least as far as the systray goes, well, we're not done yet. You still have to do the make sure it works for dialogues, and then make this thing. And so that's not done yet. Okay, see you.